This is section 4.6, using more than one pair of congruent triangles. If we look at this picture that I have drawn here, in orange on the left there are a lot of triangles pictured there. We have the four triangles individually that we see there. Plus we also have triangle ABD, or triangle BCD, or we can look at the top half, triangle ABC, or the bottom half, triangle ADC. So we can play with those pairs of triangles and see if we have different pairs congruent, and see if they relate to each other and tell us things about the other pairs. This will all take place in the form of a proof. And in this proof we're given that angle 1 is congruent to angle 2. So let me mark those as being congruent on my diagram. Angle 1 is congruent to angle 2. And angle 5 is congruent to angle 6. Angle 5 is congruent to angle 6. And I want to prove that AC, segment AC, is perpendicular to segment BD. Remember, perpendicular means they form a right angle. So one way to prove it, let's try to think backwards to see how we're going to get where we want to go. If we want to show that AC is perpendicular to BD, one way to do that is to show that either angle 3 or angle 4 is a right angle. If I can show that those are right angles, then I will know AC is perpendicular to BD. Well, one way that I can show that 3 and 4 are right angles, since I know that they have to be supplementary, they make us straight angles, they have to add up to 180. If I can show that angle 3 equals angle 4, then I'll know that they both have to be 90 degrees. So I want to show now that angle 3 equals angle 4, and that will get me my perpendicular lines. Well, how could I show angle 3 equals angle 4? I can do that if I can show that angle 3 and angle 4 are somehow corresponding parts of some pair of congruent triangles. Okay, well, they are both angles of the triangles ABE and ADE, where E is that little point in the middle there. So if I can show that triangle ABE is congruent to triangle ADE, then I'll have angle 3 corresponding with angle 4, and corresponding parts of congruent triangles are congruent. So now my goal is then to prove that triangle ABE is congruent to triangle ADE. So I look at what I have, and I know I've got one pair of angles already congruent, and I've got they share the side AE, but I don't know any other information. So I'm going to have to use other triangles to figure that out. Because I know angle 5 and angle 6 are congruent, maybe I can use that to get a different set of triangles congruent that will let me prove what I want to show about triangle ABE and triangle ADE. So that's just the way I'm thinking through this. I started with where I wanted to end up and thought backwards, maybe where I could get there. So let me start with what I'm given. Angle 1 is congruent to angle 2, and angle 5 is congruent to angle 6. Given. Alright. Now, if I look at what I'm given, I've got these two pairs of angles. Those are part of the triangles that make up the top half and the bottom half of my picture. And I can actually then show that triangle ABC is congruent to triangle ADC, as long as I have the pair of sides between that pair of angles. And I do because I know AC is congruent to itself. AC is congruent to AC, which is, of course, as you know by now, the reflexive property of equality. I had to state that because that is the pair of sides I'm going to use to make my next statement. The top triangle, triangle ABC, is congruent to the bottom triangle, triangle ADC. And look at what I used to show that was true. Two pairs of angles, and then the pair of sides between those pairs of angles. So So angle, side, angle, which is a postulate. Okay? So now I've got one pair of congruent triangles. This pair of congruent triangles is going to give me information about the other pair of congruent triangles that I'm interested in. I'm interested in showing that triangle ABE is congruent to triangle ADE. That way I'll get angle 3 congruent to angle 4. And I said, if I know those are congruent, then I know they both have to be 90 degrees because those will make a straight angle. They have to add up to 180. If they're congruent, they both have to be 90. And if those are both 90, then I have the perpendicular lines that I want to show. Okay? So if I want to show that those two triangles are congruent, I can use this pair of congruent triangles I just wrote. And that pair of congruent triangles tells me, say, AB, segment AB, is congruent to what? What does AB correspond to? It corresponds to AD. So AB is congruent to AD. And why do I know those are congruent? Because corresponding parts of congruent triangles are congruent. Okay, so now I know that AB segment AB is congruent to segment AD. But I also know AE is congruent to itself. So let's state that. AE is congruent to AE. Again, reflexive property of equality. So, I know then that triangle ABE is congruent to triangle ACE. Why do I know those are congruent? Well, I stated in my given that angle 1 was congruent to angle 2. And I know AB is congruent to AD. I stated that in statement number 4. In the statement number 5, I stated that AE is congruent to itself. So by side, angle, side, I know triangle ABE is congruent to triangle ACE. Now, angle 3 and angle 4 are corresponding parts of those triangles. So angle 3 is congruent to angle 4 because corresponding parts of congruent triangles are congruent. And then I said, well, if I can show that 3 and 4 are equal, then I know they both have to be 90 degrees. And if they're 90 degrees, then the lines are perpendicular. And I can actually jump straight to saying that AC is perpendicular to BD. Because I had a theorem way back when we talked about perpendicular lines. I had a theorem that said if lines form congruent adjacent angles, then those lines are perpendicular. So what I've shown here is that angle 3 and angle 4, which are adjacent, are congruent, and the lines that make them must be perpendicular according to that theorem. So my reason is going to be that theorem. If lines form congruent adjacent angles, then the lines are perpendicular. That is probably the longest proof we've looked at so far in this class. 8 steps. with 8 reasons. And that's the shortest way we can do that proof. We can go about that proof. We can break it down into what we might call key steps, the significant steps that led us to where we wanted to get. The first of those key steps was to show that triangle ABC was congruent to triangle ADC. We did that by angle side angle. From that, we knew AB was congruent to AD, because corresponding parts of congruent triangles are congruent. And then our next key step was to show that ABE was congruent to ACE by side angle side. I'm skipping these minor steps in between just to highlight what the key significant steps are that got us where we wanted to go. And from that pair of congruent triangles, I know angle 3 is congruent to angle 4, and finally I got what I wanted to get. Using that theorem. So I can break it down into 5 key steps. And I can write those key steps down here. We started with triangle ABC congruent to triangle ADC. By the way, in your notes, when I check them next class, I'm going to look for that proof that we just did in this list of key steps. So you need to have both of those. And this was by, and I'll just write it in parentheses, angle side angle. The next key step was to show that AB is congruent to AD. And we did that. We did that because corresponding parts of congruent triangles are congruent. Our next key step was to get the other pair of congruent triangles. Triangle ABE was congruent to triangle ADE. We did that one by side angle side. That gave us angle 3 congruent to angle 4 because corresponding parts of congruent triangles are congruent. And finally, that gave us the perpendicular lines that we wanted. AC perpendicular to BD, because we had congruent adjacent angles, which implies perpendicular lines. So a list of key steps is just a list of the significant steps, significant rocks along our path, along our journey to get from where we start to where we end. The little details, the minor steps in between, are there in the proof. We can leave them out if we're just getting an overview of how the proof works. Here's an example of a list of key steps without a proof associated with it. So we will supply a reason for each key step. And you should write down this example, including the picture, in your notes. What we're given is the picture and the information that's marked on the picture. So we have some congruent sides and some congruent angles on the picture. The first key step is to show that triangle BOX is congruent to triangle DOY. So we look at the picture and what we have, and we think, what would we need to know in order to show that? We already have one pair of congruent sides. XO is congruent to OY. And we already have one pair of congruent angles for those triangles. Angle BXO is congruent to angle DYO. We would need something else to be able to show that these are true. Well, we know we have vertical angles here. So the reason for this key step would be angle side angle. That's what we would use to show that that was true. The next key step, if we were writing this out of the proof, the next key step so not necessarily a minor step, but a key step, is to show that bx is congruent to dy. That comes straight from these corresponding parts of congruent triangles. So the reason would be corresponding parts of congruent triangles are congruent. The next key step is to show that triangle ABX is congruent to triangle CDY. Well, we just showed that BX is congruent to DY. BX is congruent to DY. So how do we know that triangle ABX is congruent to triangle CDY? Looks like we have two pairs of sides congruent and the pair of angles between them. So it's going to be side angle side. And then from that we get that AB is congruent to CD because they correspond in those triangles. So corresponding parts of congruent triangles are congruent. So instead of supplying a full proof, all we did was we were given a list of key steps, and we gave the reasons just for those key steps. In order to do that, we had to reason through some smaller steps, like the fact that we had vertical angles congruent. We didn't write it down because we were only listing the key steps. Here is your immediate practice problem. Same idea as to that example, and I've written at the bottom of the screen, draw the picture. If you do not draw the picture in your notes, you will lose points for your notes. Draw the picture. On the right hand side in orange are the key steps, 4 key steps. You're trying to show that AS is congruent to DT. You have 4 key steps. You're giving a reason for each key step. So why is triangle ABC congruent to triangle DEF? Why then do you know that angle C is congruent to angle F? Why do you know from that triangle ACS is congruent to triangle DFT? And why do you know from that AS is congruent to DT? To supply a reason for each of those key steps, as if this were a full proof, but it's not a full proof. It's missing some of the minor steps. You're just supplying the reasons for those key steps. And that is the end of section 4.6.